Hi, everybody. Today, we're going to work our way through, as you can see on the title at the top, multiplying and dividing monomials. So I'm going to call today kind of that first day where we make a bit of a leap, where we take a leap into really stretching how we can deal with some of our algebra. So I think you're going to find that what we work through is going to be all review. It's just a matter of now we're going to take everything we've discussed, a lot of that powers work previously, and now with our new terminology and our vocabulary, we're going to take that next step. So even though today is a new topic, it should kind of feel like a review day where we've just thrown everything together. So I'd like you to just take a look at that first screen that you can see, and I'd like you to try to go through as fast as you can go and fully simplify each expression. I'm hoping that what you see on the screen is going to almost act like a little bit of a practice quiz. Okay? So let's go ahead and get solutions to all three. Pause the video now. Okay, we're back. And so, to then be able to work our way through, I'm hoping that we were pretty quick, that we took a look in the first scenario and we said, okay, well, I'm multiplying powers of the same base. Therefore, I'm going to add those exponents. Base stays the same. In question B, we've used that as I have a power all raised to another exponent. So that means that I multiply my exponents. Base stays the same. And in question C, we could have taken a couple different routes through. Perhaps we put on the blinders a little bit and we said to ourselves, hey, look, I'm dividing powers of the same base, so I'm going to subtract those exponents. But then we get to an instance where maybe we walk ourselves into a little bit of a problem. That is, we just created an expression where we have a negative exponent. And we know that we can't finish with a negative exponent when asked to simplify because it doesn't make sense. And so you have to move that power across its fraction line, and we come in on 1 over n to the exponent positive 8. Okay, I want you to take a look at those three. Those three should have acted like a practice quiz. And I'm hoping you can see that basically those three was a little quiz on, do you know your power laws? What I want to do is I want to take a look at question C one more time, and I just want to address it with an alternate solution. That I need you to know that if I was to ever tackle question C, I'm not dealing with it that way. And what I want to maybe push you towards is what I said about your methodology on C. If you put the blinders on, that would be what you would produce, the red solution. But if we pull off those blinders and we think about the problem a little bit, we don't just truck through with laws or rules, then I'm hoping that we can see that question C is just a fraction. And that fraction can be reduced. That we notice on the top of the fraction line, we have 2 n's. We have an n squared. On the bottom of the fraction line, we have 10 n's. So if I was to divide out 2 n's from the top and the bottom, then that would leave me with just 1 over n to the 8th, and we could go straight to a final expression. So what I want you to watch out for today is, do we create a problem? Notice in the red solution, we created an issue. We created an expression with a negative exponent. We had to deal with that. That there may be some ways where we can work on it where we don't introduce the problem of a negative exponent. Okay, what we're going to work our way through today, again, multiplying and dividing monomials. So we're all good with our vocabulary. We should be good to jump in. Okay, let's go. Okay, what you see now on the screen is really what we're going to deal with today. And yes, some of our expressions are going to get a little uglier as we work our way through. These would all be considered pretty straightforward expressions. But what I want to address is maybe a process for us to be able to work our way through these. Okay, first off, we got to talk terminology. You remember the title for today, multiplying or dividing monomials. And all I'd like you to do is quickly scan your way down all three problems. And I hope that you can see that in each one of these problems, we are multiplying. We don't see an operation in between, we know it's multiply. I would also hope that we can see within each one of these problems, we have a monomial times a monomial. Okay, this is where some of our vocabulary and terminology can actually get a little confusing. I need everybody to understand that what I've highlighted in blue, like an underline or an overline, they're also monomials. Okay, if we recall, addition and subtraction signs separate terms. Let's focus in on question A. Do you see any addition or subtraction signs within that expression of 4x times 8x? No. So if we don't have any addition or subtraction signs, then that is one term. So the blue expression is itself one term. But if we kind of zero in and if we inspect that one term, you'll notice that that one term is made up of a term times a term. So you can kind of get a little confusing. The one term has two terms as its components, a term times a term. So everything within that expression is a monomial. We need to fight the urge to want to see the 4x and the 8x as two different terms that come together to give a binomial. Remember, 4x plus 8x is an unsimplified expression. But right there, that looks like a binomial because you have two terms. We just need to make sure that we get some practice considering. Okay, so I can have one term, but it could be made up of multiple terms. We're going to keep working our way through it as we go. Okay, even with the green and the blue underlines, we should be able to tackle each one of these problems. And so let's focus in on A. We notice that question A says take 4x and multiply it by 8x. So we need to take that monomial and multiply it by another monomial. I want to give you a bit of a process to work through that. I wouldn't necessarily call it an algorithm, but it could be. You could view it as a step-by-step process. My guidance to you would be this. Deal with the coefficients first. Deal with the variable second. And I think if you do that, you're going to find we can take a lot of monomial times monomial situations and we can make them pretty standard. So what I mean in this instance is I'm going to write down a different line. I'm going to put it in red. I don't want red to be a part of my final solution. I don't want it to be part of my solution at any step, but I think it will help us in the grand scheme of things. I'm going to break up the 4 and the x in the first set of brackets, and I'm going to use my old dot multiplication symbol. That first set of brackets says take 4 times x. My next set of brackets says take 8 times x. Now, I'm hoping that we can look with that red line, the only operation I have in there is multiply. And since it doesn't matter what order I multiply in, I can get rid of my brackets. Those brackets don't matter. Now, I just changed the operation, so I need to make sure that I put that next multiply in there. Well, if you take a look at that now, you see I have 4 times x times 8 times x. And here's where I would argue to you that little algorithm can help. Since it doesn't matter what order I multiply in, then let's multiply our coefficients first. So there is my 4 times 8. I get my 32. And now I deal with the variables. What is an x times an x? Well, that's going to give me an x squared. Here's what I'm talking about when I say putting the blinders on. That I would have a bunch of people that may look at x times x and they view that as like a law of exponents problem. And they go, okay, I know when I'm multiplying powers of the same base, then I add my exponents and we come to an x squared. I would hope that in an instance like this, we don't think of that as a law of exponents, but instead we view it as writing something as a power. How can we write x times x in a better form? Well, that's just x squared. Something times itself is that something squared. So I need you to be aware that when I went through and simplified that to 32x squared, and I multiplied x times x, there was no part of me that was thinking law of exponents. That was me just going an x times an x is an x squared, because that's a power. Okay, I think we've blabbed enough on theory in the first question that I think we can see within B how we can get there. We take a look at question B, and I'm going to bet and say, I think I already have enough people that could try B on their own and be solid. So I think we're at the point where we can start pausing the video and giving everything a try on our own. Okay, so let's pause it now if you want to give it a shot. Otherwise, you're coming with me. Okay, if I was to follow that same algorithm, I notice the question, the expression in B, is something times something, and both of those somethings are monomials. So I can deal with that by multiplying the coefficients. -2 times 3 gives me my -6. And now I multiply my variables. Well, I notice that my first part of my variable is an a to the 4th, and my second part is an a squared. Now, maybe I view that and I say, hey, laws of exponents say, if I'm multiplying powers of the same base, a to the 4th times a squared, then I add the exponents, base stays the same. But we could also view that as simply a power. A to the 4th means 4 a's attached by multiply. If I multiply that by an a squared, that means 2 a's attached by a multiply. That we should be pretty solid to almost even just think of it as a power and say, well, I've got 4 a's times 2 a's, so there's my 6 a's. And we can come straight in on that final term. If you use laws of exponents on that one, I don't think that's bad at all. Okay, hopefully we matched up for those people who are trying it on your own. And now I think we should be able to, even if we encounter something that's a little puzzling, be able to attempt all of the next problems on our own. Okay, so I want you to give C a shot. Pause the video now. Okay, we're back. Now, C may have caused us a little bit of difficulty, which gives us great problem-solving practice. Because we notice that both the monomials that we're multiplying have different variables. So I'm just going to go through and I'm going to write out that red line that we did on question A again. That expression would be a 2 times x times 4 times y. And if we come in on that line, then what we'll notice is it's all multiply, and it doesn't matter what order we multiply in. So I still have the ability to simplify the coefficients. 2 times 4 is 8. But I can't do anything to simplify my x times my y other than write it in a more efficient form. That is, don't bother writing in the multiply. So for me to write x times y, I'm simply going to write xy. All that we were able to simplify in question C was the coefficients. Okay, hopefully we matched up. Okay, all we're going to do for the rest of the day is tackle some uglier and uglier expressions. I might change up the I will change up the operation on you. But that's all we're going to deal with. Can we start to do some monomial operations? Okay, let's jump into some more. Okay, so now you can see on the screen that we've made a jump. These look considerably uglier than the ones we began with. I think we're prepared to be able to work our way through. So I want everybody to take a shot on D. Pause it now. Okay, we're back. So you take a look at D, and we notice they're a little more complex because now I have multiple variables within each monomial. No worries. Follow our process. Deal with the coefficients, then deal with the variables. So when we take a look, I can multiply my coefficients. Now I start to multiply my variables. Well, as I start to go through and combine or try to simplify my powers of x, I notice that I have 1x in the first monomial, 2x's in the second monomial because of the x squared. Well, if I go to put together by multiplying the 1x and the 2x's, then I have 3x's, so an x cubed. I now address my powers of y in the same way. I have a y squared times a y to the fifth. I'm hoping we can see that as 2y's and 5y's. However, if we struggle, then we can say, hey, I know my law of exponents. When I multiply powers of the same base, I add those exponents, and we come in on the same thing. Okay, hopefully we matched up, and we're feeling a little more comfortable with it. Let's use E as a bit of a gauge. Okay, I want you to pause the video and work your way through E. Pause it now. Okay, we're back. So there shouldn't have been too much to cause us problems on E. Multiply your coefficients. Multiply your powers of M. Multiply your powers of N. And if we got down to negative 20, m to the 7th, n cubed, then we should be feeling pretty confident. Okay, we should feel good about multiplying monomials. Now let's change gears a little bit. Okay, so what you see on the screen is the same instruction. It's to simplify. I just want to make sure that this looks like a separate section in your notes. So that's why I've called it question 3 as opposed to like question E. So I'd like you to be able to go through as fast as you can and just get a solution to question A. We're going to take 18x cubed and we're going to divide it by 3. Okay, pause it now. Okay, we're back. So I think if we were to talk about this problem a little bit, I'm hoping that we're good on what the operation of division means. Really what you're trying to do is you're trying to take 18x cubes and you are trying to break them up and trying to work your way through into 3 equal groups. Now, I'm hoping in that process, we would be pretty comfortable to simply say, well, then that must be 6x cubed. Hopefully we have some confirmation and we're pretty solid on the y, but I want to make sure everybody's good on that y. I'm just going to write in one more line to make sure that we're comfortable, and it's going to look weird because I'm not going to change up the line very much. What that is it's 18 times x cubed all over 3. What you have is a fraction. And what I can do to simplify is to reduce the fraction. And we'll notice that I can do this operation of 18 divided by 3. So really what I'm doing then is I'm saying I can divide out a 3 from the bottom, and I can divide out a 3 from the top. Now, for anybody that's looking at that and they're going, but hey, wait a second, why didn't we divide out a 3 from the x cubed? I want to come back to our terminology. How many terms is 18x cubed? We should all be good that that is one term because we do not see an add or subtract. It is one term. So, down on my red solution, when I divided out my 3 to get my green numbers, I divided the whole term by 3. When I divided it out of the 18, 18 is part of the 18x cubed term. I did do the division. So what does that take us to in terms of process? Really what that means then is for me to simplify that expression, I can just divide my coefficients. Yeah, do my division operation between my coefficients. Okay, without much more discussion, I think we're good to start jumping in on our own. I'm not saying that we feel 100% confident to do so, but I think you might surprise yourself. So I want everybody to work their way through B now. Okay, pause the video now. Okay, we're back. So I am hoping, without even talking about this in this context, you guys can see that deal with your coefficients, then deal with your variables. That process still applies to dividing monomials. I have my 18 divided by negative 9. I can calculate that. Negative 2. And now I have my variables. X to the 6th divided by x squared is an x to the 4th. And for everything that I mentioned previously, yes, you could view that as, hey, I'm dividing powers of the same base. So I subtract my exponents and view it as a law of exponents problem. Nothing wrong with that. It gets you to your final solution. But what I would really love you guys to do is to work at it as a simplifying a fraction problem. How many x's do I have on the top? 6. How many x's do I have on the bottom? 2. Which side of my fraction line has more x's? The top. By how many more? 4. So I'm just going to divide out my common factors of x and go straight to an x to the 4th. Okay, we've got a number of different ways to think about it now. Let's keep that process going. Deal with your coefficient, deal with your variable. Okay, we've got some uglier expressions now. I want you to work your way through C. Okay, pause the video now. Okay, we're back. So here is going to be one where I'm going to argue. I tried to put you in a situation that might jam you a little bit as to how you wanted to write this expression. Okay, let's start off at the very beginning. Deal with your coefficients. We can see that we have 8 divided by 16. And I am going to have some decimal junkies out there that are going to go 0.5. Hey, nice. And that is 100% correct because 0.5 is exact. I'm just going to argue to you that as time goes on, you're going to see that less and less. That my hope for us is to actually go through and keep it in fraction form. So rather than calculating your 8 divided by 16, let's simplify. Between your coefficients, do you have a common factor? Yes. The largest common factor that we can divide out is an 8. So I'm going to divide it out of the top, divide it out of the bottom. And that gets me a 1/2 as my coefficient. Okay. Now my second step is to start dealing with my variables. So we should be okay to jump into both variable parts of those terms at the same time. Okay, take a look at your fraction. Which side of your fraction line has more x's? The top. By how many? 2. So we should have an x squared. Now, I could ask that same question with respect to the y's, but I am hoping that on quick peek, you guys notice, hey, we have the exact same number of y's on top and bottom. And so if I view that as a fraction where I'm simply reducing, then my y's are going to divide out. Now, for all you laws of exponents junkies, and I say that like it's a bad thing. It's not a bad thing at all. But if we were to view that, you would notice, you would say, hey, I'm dividing powers of y by the same, dividing powers with the same base. They both have base y. So I subtract my exponents. And I'm going to take my 1 minus my 1. That gives me 0. I just hope that we can be reminded then, look at that blue y to the exponent 0. We know that that's equal to 1. So why ever write it down? And there we go. So if we came down to a 1/2 x squared, we are good. If you wrote down 0.5 x squared, you are correct. It's not even bad form. As I said, I'm just going to argue to you, we want to get used to the fractions. But we are also good if you wrote down x squared divided by 2. Because we should see that my gold answer of 1/2 x squared can reduce to x squared over, I shouldn't say reduce because it's not reduced, can be manipulated or changed to look like x squared over 2 by just doing my calculation of my fraction times a whole value. So any one of those 3 values would be acceptable forms for your final solution. I'm going to push you for the gold one though. I think the gold one is your best form. Okay, I'm not saying that we're not going to address snags. We're going to address snags still, but I think you should be feeling more confident about jumping into D. So I want you to pause the video, give D a shot. Okay, pause it now. Okay, we're back. So I'm hoping that the coefficients were not an issue for this one. That we took a look at the 8 and the 6 as coefficients, and we said, hey, both of those are even. I could divide out a 2 from the top and the bottom. So if we got to that, I think we're doing great. Now, I want to walk through this process in a way that I have not suggested. I have made some comments about you blindly following your power rules. I really want to show you a little bit here what can happen if you do. So let's address our powers of m. I have m to the 8th divided by m to the 5th. I am dividing powers of the same base, so I subtract those exponents. Base stays the same. Now I address my powers of n. Okay, I am dividing powers of the same base. That means that I subtract those exponents. Base stays the same. And we notice that we just created a bit of a problem. We have a negative exponent, and we know that we can't finish with negative exponents because they don't make sense. So how do we now manipulate this one? Well, sometimes people take a little bit too long to maybe get there. Like they put in some extra steps. This would be acceptable. It's 100% correct that we know to change the sign of the exponent on n, we can move it across its fraction line and get to that. 100% correct, what you see in green. However, we should acknowledge that that is not fully simplified, because now you have a fraction times a whole value, m cubed, potentially whole, times my 1 over n squared. We would be expected to clean all of that up. And so what we end up getting then on top of a big fraction line is the 4 times the 1 times the m cubed. And then on the denominator, we're going to have a 3 times an n squared. And if you came in on 4m cubed divided by 3n squared, you have a great expression for that. A great fully simplified expression. Okay, what might be a better way to work through this? I want to walk through this solution an alternate way, and this would be the way that I would tackle it. And you'll notice that I'm going to use a lot of the wording that we discussed before. I just might manipulate the way I write it down so that I have a proper solution. I'm going to go straight to my final answer. Okay, I take a look at my coefficients and I notice that, hey, I can reduce by dividing top and bottom by 2. That still gets me my 4/3. Now I take a look at my powers of m, my variables, but I'm not going to blindly follow my laws of exponents. I'm going to go back to the way we were talking about it previously. Look at your big fraction line. Which side of that fraction line has the most m's? The top. By how many? 3. So on the top of my fraction, therefore I have to extend my fraction line, I need to put in an m cubed. Okay, and now I jump to my powers of n. Okay, which side of my fraction line has more n's? The bottom. By how many? 2. So I need to include an n squared on my denominator. And you'll notice you can come straight in on your final expression. Similar to what I mentioned before, that's going to allow us to avoid creating a negative exponent problem. I think you guys might really like the purple. And my suggestion to you would be, try to use the purple. We know we can always fall back on the gold and then manipulate it using the green. Okay, hopefully we're feeling more comfortable with dividing monomials. Let's jump into the next section. Okay, for everything that I mentioned earlier, yes, we're still simplifying, but in your notes, I'd like this to look like a separate question, just so we can group some things together. So when you take a look at question 4a, it has the same instruction as simplify, but we're going to group everything. You'll notice that question 4a looks a little different. And you may also notice, hey, this doesn't really fit in with the title for today. And I'm going to argue to you, this is the next step. That what we end up having is a power. It just so happens that that power has a monomial that's a little uglier than what we're used to as its base. Notice, if I let that ugly base of 2x squared y equal something else, like an a, well then that expression is just a cubed. It's a single power. And we should be comfortable with single powers. It's just that the base has been made a little uglier. So I think we should be okay if we walk through this first one, and then I can let you go for the rest of this lesson. I'm going to write down one step. It's going to look a little weird. It's going to look like a bit of a pain. I never require seeing this. Remember what cubed means. It means that I have 3 of my bases attached by multiply. So it means that I have a 2x squared y times a 2x squared y times a 2x squared y. So maybe you can see now why question A really does fit in today's topic. Can you see that we are multiplying monomials? However, I never want anybody to have to write that down. Especially, imagine what if I said, no, my exponent wasn't 3, but it was 30. Like, you don't want to sit there and have to write out 30 2x squared y's. However, if we take a look at the red, we should be able to see really quickly why my answer would be 2 times 2 times 2, x squared times x squared times x squared, y times y times y. Now, if I'm telling you that you don't have to write down the red to get to the gold, then how can we see it from the original expression? I'm going to put a line through it. I want to keep it there, but I'm just going to put a line through it. We're not writing that down. If we can recognize that I have a monomial as its base, a single term, then what do I do if I have a single term raised to another exponent? I need to apply that exponent to all parts of its base. And so what you'll notice is I actually have a law of exponents issue here. That what I have when I apply that whole thing would be a 2 cubed, then times an x squared, that's cubed, then times a y, that is cubed. Well, the first thing we should be able to see, 2 cubed gives me my 8. But the middle part of that term is a power raised to another exponent. There's our laws of exponent situation. If I have a power raised to another exponent, then I have to multiply my exponents, and there is my x to the 6th. Now, maybe you look at it as a law of exponents question. However, I would hope that we can just see the y all cubed and write it as y cubed. Okay, if we're good with that, then I think I'm going to have a bunch of people that could jump into problem B. So I'd like you to work your way through B. Pause it now. Okay, we're back. So I actually think that our mistake, if we made one on B, is actually going to be something on what we would kind of call like silly. It would be a silly common mistake, but it would still be silly. And you're actually going to look at it and go, oh, I really actually have a good understanding of what I'm doing. I just goofed up on something silly. So we take a look at that and we notice we have a monomial base all raised to an exponent. So what do? We apply that exponent to all parts of the base. Well, the first mistake that we may have done, if we got really focused on laws of exponents, was we may have written this, -3, x to the 12th, y to the 4th. And I'm hoping that by me writing that down, you can see my mistake. You'll notice I applied my squared to the y part of the term. A power raised to another exponent means I multiply those exponents, so I got my y to the 4th. You can see I applied it to the x part of my term. There's my x to the 6th all squared, there's my x to the 12th, but I totally forgot to apply it to my coefficient. Easily the most common mistake, easily. So I know that nobody made that mistake, and instead you guys wrote down -9, x to the 12th, y to the 4th. Now, I'm hoping that you're like screaming at me through this video, that you can see that that's still wrong. But I'm going to expect that if you applied that exponent to all parts of the base, that is going to be the mistake you make. Look how silly that mistake is. What's -3 squared? It's a +9, not a -9. And there we go. So if you got down to 9x to the 12th, y to the 4th, I think we've already got the concept. Now all it becomes is, can I start to challenge you a little bit and make this stuff even uglier? Okay, here we go. Okay, you take a look at C and D, and things are starting to get uglier and uglier by quite a bit. So let's get into some problem solving right now. Okay? Because the expressions got a little uglier, then it shouldn't surprise us if our solutions maybe became a little longer in terms of number of steps. I want everybody to give C a shot. Okay? This is pure problem solving. You have all the theory that you need. However, you are jumping into a problem that does not look like any one we've done before. Okay, best of luck on C. Give it a shot, pause it now. Okay, we are back. So I'm hoping that when we took a look at C, we can recognize that question C is really just two problems like A or B that are being multiplied together. So I hope that we can see that question C isn't more difficult, it's just more. Like, it's not like it's more complex. It's not. It's more work. So let's take the strategies that we learned on question 4A and B and let's apply them here. Okay, my first step then, simplify the first power. So that means that I have my cubed and I need to remember to apply to all parts of the base. Okay, that means -2 cubed gives me my -8. X squared all cubed gives me an x to the 6th. Y cubed. Now, as I work my way into the next monomial, that next power, I can see that there's no operation in between. And I know that that means multiply. So I'm going to put brackets around that first monomial to make sure that I maintain that multiplication operation. And now I can do the same thing in the second power. Take my squared and apply it to all parts of the base. So I need to square my 3, square my x, square my y squared. If we got that line down, then I think we're doing really solid. What you will notice is you created a problem that fits into the question sequence of question 2. Now we have a monomial times a monomial. And so now we can multiply those monomials. Okay, if you hit a snag getting down to that line, this is your opportunity to pause the video again just on your own. You don't need me to guide you on that. And try to finish off the problem on your own. Okay, always be using that. A chance to try your stuff on your own. Okay, we're going to finish off this problem. I am now multiplying monomials, so I deal with my coefficients, then I deal with my variables. So my -8 times my 9 is a -72. X to the 6th times x squared is an x to the 8th. Y cubed times y to the 4th is a y to the 7th. And there we go. So if you were able to get down to that expression, then I think you should be feeling really confident moving forward. It means that we understand how to apply dealing with a monomial to a greater exponent, and we're probably pretty solid on our multiplying monomials. Okay, now that we've walked through that problem, this is going to sound a little weird, okay? I need you to understand. It's going to sound weird. This is a grade 6 problem. And you're going to look at that and go, it's not a grade 6 problem. I never did stuff like this in grade 6. And I'm going to go, you did. It just didn't look as ugly. I want you to look back up to the original expression. And all I'd like you to notice is all I did was follow bedmass. Look at the operations you have in the question. I've already marked the multiplication that we have in between the two monomials. I'm just going to get rid of my star, and I'm going to write that in with my good old-fashioned multiplication symbol. Well, I'm going to circle my exponents. So really all you have in that problem is a power times a power. Why do I say it's grade 6? Because grade 6 is bedmass. And so notice that all I did was follow bedmass. I applied the exponent in the first monomial. I then dealt with the exponent in the second monomial. So I followed bedmass and I dealt with the exponent first. What operation haven't I done yet? I haven't done the multiply, so now I address the multiplication in the end. It's really just a bedmass question. We've just made your language uglier. That's all. Okay, I am hoping that we feel really confident moving forward. You can maybe just see that all this is bed mass, it's just uglier. And you now have all the skills you need to deal with some complex expressions. Okay, let's finish off this lesson with you giving problems a shot on your own. Okay, let's get down problem D, that expression in D, and then I want you to get a full solution all the way down to the end. Pause the video now. Okay, we're back. Okay, I'm going to address something that I think is the common mistake in D, or one of the common mistakes. So I go through, I've got my monomial times a monomial, 3 times 2, there's a 6, a times a squared is a cubed, b times b is b squared, and that is all squared. I am hoping that you can see that that green is wrong, and I am really hoping that you didn't do that. But as I mentioned, it is a pretty common mistake. If we can recognize that that expression is just filled with operations, then we should be able to see why we just failed grade 6. Remember, failed grade 6 means we broke bed mass. When I look in my original expression, I notice I have multiply and I have exponent. And I know I have to do exponent first. So hopefully you can see why me multiplying the 3ab times the 2a squared b first broke bed mass. Okay, I'm going to get rid of all of that writing that I put down on that section. And now this is the solution I would love to see. You didn't fall into the trap. You recognized your multiplying exponent. That meant you left the 3ab out in front. Okay, so then what do we have to tackle? Well, we need to tackle now the power. That means I need to take that 2 and apply it to all parts of the base because the base is a monomial. So that is going to give me a 2 squared, an a squared, squared, and a b squared. And as I said, if we're following laws of exponents, like we have an a squared all raised to the power of 2, that means I have to multiply my exponents. We should get down to that. And now we can simplify that expression. Deal with your coefficients. And since I'm multiplying in an AB, then that means that I need an extra A and an extra B. And as I said earlier, if we're multiplying powers of the same base, we add the exponents. We can get there with laws of exponents. Okay, I am hoping that we got to that point. If there was anybody that was still kind of hanging on, I don't see why bed mass was an issue in this case, I'm just going to put down a different question for you. Like I've got 3ab out in front. Let's just say I call that 3. I have like a 2a squared b underneath. I could call that 2, but then my exponent's going to be 2, and maybe I missed something because of all the 2's. So what I might do is I'm going to replace 2a squared b with a different number, like maybe something like 5. So I've got 3 times 5 squared. I'm hoping we can see you have to leave the 3 out in front. And you need to calculate 5 squared. The answer to that expression is 75. It's not 15 squared, 225. I'm hoping that we can see how bed mass will get us through those problems. Now if we tie in some new skills. Okay, here are our last problems. Okay, I'd like you to take a look at E and F. And I want you to go start to finish on both. Okay, get down to a final simplified form and we'll check and see how we're doing. Okay, pause the video now. Okay, we're back. So I'm hoping that we had a relatively easy time working through E. I would throw E in as the easy to middle of the road expression. Okay, we take a look at our coefficients and we can divide 16 by 8. That gives me 2. Now I deal with my variables. I have 3 x's on top. I got 1 x on the bottom. That means I have 2 extra x's on top. I've got 4 y's on the top, and I've got 2 y's on the bottom, so I have an extra y squared on top. And there we go. We could have got there by simplifying the fraction, or we could have got there using laws of exponents. I'm hoping you can see why I would call question E on the easier side of middle. Okay, if you need to pause, pause. But otherwise, we're going to work our way through F. Okay, I notice I'm dividing powers or monomials. So I deal with my coefficients first. I have 25 and 35. Those have a common factor of 5. So I'm going to divide out a 5 from the top and a 5 from the bottom. And that gets me to my negative 5/7. I know I'm good to have my negative on top of my fraction. I'm good so far. Now I have to deal with my variables. So I've got powers of m, n, and p. Okay, I slowly work my way across. My powers of m. I have more of them on the bottom. And I have 3 more of them on the bottom. So I need to extend that fraction line and include an m cubed on the bottom. That is me dividing the top by m to the 5th and the bottom by m to the 5th. Dividing out all my m's. Okay, now I take a look at my powers of n. I've got 4 n's on top, I got 2 on the bottom, so I have more on top, and by how much? 2, so I have an n squared on top. That is me dividing 2 n's out of the bottom, 2 n's out of the top, so I'm left with 2 on top. Now I address my powers of p. Now I go through which side has more, the bottom, by how much? 1. Extend my fraction line a little farther, and there we go. That would be me dividing the top, p squareds out, the 2 p's out of there. Since there's 3 on the bottom, I'd have 1 left over. So if we got down to negative 5n squared over 7m cubed p, we are good. Okay, what I want you to do now is to jump in and get as much practice as you can. You really want to make this stuff automatic. Where we go in the upcoming days, multiplying, dividing monomials are going to become a small part of a lot of problems we do moving forward. Okay, a lot of problems. So I want to make sure that we're really solid with that process. As you jump in and you play around with your practice, you're going to notice you have a number of worksheets with your practice. You figure out where you need to spend your time with your practice. So maybe we need a little extra practice on a particular situation, multiplying monomials maybe. Then I would spend some extra time on that worksheet. If you feel really solid with things, and let's say that question D, E, and F went pretty well, then I think I would be jumping in on the jumbled worksheet and just working through that one. Okay, your job, jump in and get some practice. Okay, best of luck.